right, so this lesson details the differences between experimental and theoretical probability. And if you haven't seen my video on simple probability, you should probably watch that first. I'll put a link up here in the upper right-hand corner, and you can go watch that. So experimental versus theoretical probability. In my video on simple probability, what we were really doing was theoretical probability. All right, so what do you think experimental probability is? Well, look at the word, experimental. So experimental probability is basically the results of an experiment. So for instance, flipping a coin. So when we flip a coin, the theoretical probability of it landing on heads is 1 to 2, or 1/2. That's a theoretical probability. That's what should happen. But what if we actually flipped it? Is it possible that we flipped it 10 times and it landed on heads all 10 times? Yes, that's not likely, it's unlikely, but it could happen. So in theoretical probability, you actually do the experiment, in experimental probability, you actually do the experiment and record your results. And then you can compare that to the theoretical probability of what should have happened. All right, so theoretical probability is the ratio of the number of times an event occurs to the total number of trials. So again, you're going to do an experiment, you're going to keep track of your data, and your experimental probability is going to be the ratio of how many times did an event occur, whatever it is that we're looking at, versus how many times did we do the experiment, what's the total number of trials. And what experimental probability tells you is what does happen. So it's not what should happen, but it's what actually does happen. Versus theoretical probability is what should happen. All right? And theoretical probability is the probability, let me write this down, I can't speak and write at the same time, the probability of an event happening based on the possible outcomes. So this is what should happen. So when I flip a coin, half the time it should land on heads, and half the time it should land on tails. But we know that that's not always going to be true. Now, one of the keys with experimental probability is the more times you do an experiment, the closer your results are going to be to the theoretical probability. So if you flip a coin 1,000,000 times, it's likely that your results are going to be very close to the theoretical probability, meaning that half the time it's probably going to land on heads and half the time it's going to land on tails. Now, of course, it's not going to be exactly 50-50, but it's going to be very close to that. Whereas if you only did the experiment 10 times, it's possible that it won't be close to the theoretical probability at all. All right, so we're going to use the spinner below to answer these questions. Then, I'm going to try this, we'll see. I'm going to try to spin the spinner 10 times and complete the table. So we're going to do theoretical probability, and then we're going to do experimental down here. So what is the theoretical probability of spinning a section with stripes? So if you spin this, what's the probability that it would land on stripes? Well, there's one section that has stripes on it out of how many possible outcomes? There are 8 different sections on here, so the probability would be 1/8. And remember, that means that it's unlikely. So anything less than a half is unlikely. What is the theoretical probability of spinning a section with stars? Well, there's 2 sections with stars, so there's 2 favorable outcomes out of 8 possible outcomes. And we can simplify that to 1/4, which is less than a half, so we still say that that's unlikely. And then lastly, what is the theoretical probability of not spinning a solid or a striped section? So how many sections on here are solid or a striped section? Okay, so solid, there's 1, 2, 3, 4. Striped, there's 1. So that would be 5 out of 8. So 5 out of 8 are solid or striped. but it's asking what's the probability of not getting those. So what I should have said, I wasn't thinking straight, sorry. What I should have said was how many sections are not solid or striped. So that would be 1, 2, 3. So there are 3 out of 8 that are not solid or striped, and then 5 out of 8 that are solid or striped. And again, 3/8 is less than a half, so that would be unlikely. All right, so let's see if we can pull this off. But hold on 1 second. All right, so here we go. So I found a website where I could create this spinner, ignore the colors. I couldn't figure out how to get the colors different. But you can see this spinner matches this spinner. So I labeled it white, white, dots, white, stars, white, stripes, stars. Okay, so it matches this. And we're going to spin this 10 times and record our results over here. So here we go. So here's the first spin. And so I got stars. All right, so one time I got stars. The next time we got stripes. So this is experimental probability. Stripes again. So experimental probability, remember, you're actually going to spin the spinner and see what the results are that you get. So I got white, spin it again. I get stars. All right, so on it 5 times. Here's number 6. And we get white again. How about dots? Can we get dots? Stripes. We're at 7 times. And stars. I guess the spinner doesn't like the dots. Now this is supposed to be totally random, right? I'm assuming that's true. So that's 9 times we've spun it. So one more time. Oh, no dots. So we got stars again. All right. So let's look at our results now. All right. So let me widen this and come down here. And so the total number of spins was 10. So that was 10 for all of these. That's total number of times it landed on. Stripes 4 times, white 2 times, dots 0, stars 4 times. So the experimental probability is that it happened 4 times out of how many times we spun it. So that would be 4 to 10, which simplifies to 2/5. And we have 2 out of 10 times, which simplifies to 1/5. And then we have 0 times out of 10, so that's 0. Now keep in mind, what does a probability of 0 mean? That means that it's impossible. Well, is it really impossible for it to land on dots? No, it's definitely not impossible. So that's why the more times you do the experiment, the better your results are going to be. Because I guarantee you, if we spun this 100 times, it's going to land on dots, at least some of those times. So stars, we got 4 out of 10, which is 2/5. So are there any results in which the theoretical and experimental probability are the same? Let's say no. So the theoretical probability of stripes, let's look at that. So the theoretical probability of stripes, let me come up here. Remember, there's 8 sections here. So the theoretical probability was, man, I really messed this up. I moved everything. All right, there we go. So the theoretical probability of stripes is there's 1 stripe section out of 8. So that doesn't match up with the experimental. For the white sections, there are 4 of them, 4/8, which is 1/2. That doesn't match up. Dots would be 1/8. That obviously doesn't match with 0. And stars would be 2/8 or 1/4, and that doesn't match up. So then the question is, well, how come they don't match up? And the answer, I'm not going to write it out here, but the answer is that they don't match up because we didn't do the experiment enough times. So if you really want to get results that are close to the theoretical probability, maybe not exact, but very close, you want to do the experiment multiple times, way more than 10. The more you do, the better your results are going to be. All right, so let's look at this relative frequency. So what is relative frequency? Let me move this out of the way here. Relative is the total number of successful attempts divided by the total number of trials. And it can be used to make predictions. So that's why we calculate probabilities, to have an idea of what can happen so that we can make decisions. So as the number of trials increases, the relative frequency of an event will approach the theoretical probability. So that's what I was saying, that the more times you do the experiment, the closer your results are going to get to the theoretical probability. All right, so they've got another spinner experiment here for us. And they want us to spin the spinner 50 times. And then we have to spin it 100 times. All right. So they made up the numbers here for the 50 times. Okay, so we're not going to do the 50 spins, but we are going to do the 100 spins. But I have 4 spinners set up, so we'll really only have to do it 25 times. Okay, so for the 50 times, saying it landed on number 1 12 times out of 50. So the relative frequency would be 12 50ths, and we can simplify that to 6 25ths. This would be 8 50ths, which we can simplify to 4 25ths. And this would be 13 50ths, which you can't simplify. This would be 10 50ths, which is 1/5. And this would be 7 50ths. All right, so you can see that this is saying that you're much more likely, well, not much more, you're most likely to land on 3 and least likely to land on 5 based upon these results. It landed on 3 the most number of times, and it landed on 5 the least number of times. But we know that if you spin this, in theory, you have an equal probability of landing on any of these numbers. Right? There shouldn't be one number that's more likely than another. So let's spin it 100 times, and we're going to see if our results get closer to the theoretical probability. So I'm going to pause this 1 second and get my spinner set up over here. All right, so to save time, instead of spinning one spinner 100 times, I got 4 spinners, so we're going to do it 25 times. All right, so here we go. So we got 1, 2, 5, and hopefully I can keep track of this. So I got a 1, a 2, a 4, and a 5. Spin that again. If you want to fast forward to the end of this, go right ahead. You have the advantage over me. You can fast forward. So 2 1s, a 4, and a 5. So 3 1s. 1, 2, 3, and a 3. Cross these off to keep track of this. So 1, 2, 3, 4, 5. There's 5. All right. 3 fours. 1, 2, 3. And a 2. 1, 2, 4, 5. So 1, 2, 4, and 5. I just realized I'm marking these wrong. That's actually 6 right there. So hopefully you fast forwarded through this. So 2, 3, 4, 5. Add another one here. Should be 1, 2, 3, 4, 5. And another one here. And now we have 1, 3, 4, 5. So 1, 3, 4, and 5. 2, 3, 4, 4. 2, 3, 4, 4. 1, 2, 2, 5. 1, 2, 2, and 5. 1, 1, 2, 5. 1, 1, 2, 5. 1, 2, 4, 5. 1, 2, 4, 5. 2, 2, 4, 4. 2, 2, 4, 4. 1, 2, 4, 4. 1, 2, 4, 4. I should probably stop and count how many I've done. 1, 1, 4, 4. So 1, 1, 4, 4. Let me check. So I have 5, 10, 15, 20, 25, 30, 35, 40, 45, 47, 49, 52, 53, 54. So we're only like halfway there. Bug. 2, 2, 2, 5. So 1, 2, 3, 5. 4, 4, 5, 5. 4, 4, 5, 5. And 2, 2, 5, 5. 2, 2, 5, 5. It's not landing on 3 very often. 1, 4, 4, 5. So 1, 4, 4, 5. 1, 2, 3, 3. 1, 2, 3, 3. Yay for the 3. 1, 2, 3, 5. 1, 2, 3, 5. Gotta be getting close. 3, 3, 4, 5. 3, 3, 4, 5. So let me count again. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 72, 75, 882. Somehow I must have miscounted somewhere because this isn't coming out to an even number. So let's see, 1145. So 1145. 2344. 2344. 2245. 2245. Should have kept count. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 87, 88, 92, 93, 94. So I need 6 more. So 3 ones and a 2. 1, 2, 3, and 2. And I'm just going to take A and B on this one. A and B. So 2 and 4. 2 and 4. All right, so let's look at our relative frequencies now. Make this guy bigger. All right, so this is out of 100 tries. So for landing on 1, it happened 5, 10, 15, 20, 24 times out of 100. And that would simplify to, let's see, 4, that would be 6, 25ths. And this one is 23 out of 100. The 3 was only 9 out of 100. The 4 was 27 out of 100. And the 5 was 5, 10, 15, 17 out of 100. So we're still not exactly with the theoretical probability, but you can look and see that we're getting closer. All right? So the more times you do this, the closer you're going to get to the theoretical probability. That's the whole point of this. So what did you notice as you spun the spinner 100 times? Well, I noticed it took forever. Sure, you know, well, hopefully you didn't notice that because you fast forwarded. The other thing that we notice is that we get closer to the theoretical probability. All right, so what is the theoretical probability of spinning each of the numbers? So there's 5 sections, so the theoretical all of these is the same, which is 1/5 or 20%. Remember, to change 1/5 into a percent, you could just do 1/5 equals x over 100. Cross multiply and divide, and you'll get 20%. So that's part over whole equals percent over 100. And so all of these theoretically have the same likelihood of being landed on. So how does the relative frequency change between when the spinner spun 50 times versus 100 times? Your experimental probability will get closer to the real theoretical probability. So suppose the spinner is spun 1,000 times. Predict the relative frequency of each spin. Well, it's probably not going to be exactly 1/5, but if we're going to make a prediction, we would predict 1/5. Right? I mean, it might not be exactly that. It probably wouldn't be exactly that, but it would certainly be closer to that. All right, so hopefully you have an understanding of the difference between experimental and theoretical probability. So theoretical probability is what should happen. Experimental probability is what actually happens. So hopefully that was helpful. If so, give it a like and a subscribe. And until next time.